In the second half of the 19th century, Maxwell brings order in electromagnetism with his famous field equations. From these, waves equations are derived, and it turned out these waves move at sea in vacuum. Since light has been also measured at sea, the agreement led to assume light is an electromagnetic wave, despite this agreement proves nothing. All non-mechanical waves propagate at sea. Gravitational waves are example. Otherwise, by this coincidence, we could also consider gravitational waves as electromagnetism. The Einstein equation shows how energy can exist in different forms that can be quantitative equivalent, but they are not qualitative comparable. So, even if charged particle emits light, there is no implicit reason for this radiation to be electromagnetic. Energy can be transformed and change quality. From Maxwell, we can extract a mathematical solution for light. It's described as fluctuations between minima and maxima of the two orthogonal electric and magnetic fields. At macroscopic scale, we know induction as some form of interaction between two systems. A changing electric field in one system becomes magnetic field in the other, and vice versa. And it is shown alternating because we convert energy, and as usual, we must obey conservations. So induction occurs in a system perceiving changes in external fields, because no one sees its own field. With light is different because the wave is explained with self-induction. It's always critical to theorize a fundamental system capable of do work on itself. Here, electric and magnetic fluctuations are in phase. They grow and shrink at the same time. Each one is inducing the other. They are both cause and effect, so there is no maxima to reach because there is no reason for the growth to stop. It's an endless self-reinforcing loop. Even if we accept some additional factor which can constantly steer this behavior into fluctuation, we still have inconsistency with conservation of energy and cause-effect relations. And as soon as they reach the minima, there is nothing left to induce the following growth. So the concept is littered with gimmicks to make it work, and with this self-induction, it is also explained the self-propagation for light with no medium. Anyway, one would reasonably expect some form of interaction between light and electromagnetic fields. However, besides its definition, light is not affected neither by electricity nor by magnetism. Even crossing non-uniform fields, its path won't change. What should be fluctuations of the electromagnetic field is completely ignoring both electric and magnetic fields. Even within cases as the Faraday effect, electromagnetism of light is assumed. In 1845, Faraday was performing many tests when, with a piece of glass and two magnets, he sees the transmitted light changing polarization. And he states this is proving the relation between magnetism and light. Light doesn't care about magnetism, but interacts with matter. And it's no wonder that, for as much the magnetic field can affect the material, so much is changing the resulting interaction between matter and light, in a way that is not conceptually different from this. So here we are not proving light is electromagnetism, because matter is the inevitable intermediary. Thus, light and magnetism have no direct relation. The same is observable with Stark and Zeeman effects. The splitting of the spectral line is showing what is locally occurring. It's the projection. The magnetic field affects how particles are arranged, and this must have consequences in light-particle interactions. If you change the conditions, you change the result. But it's not about magnetism or electricity splitting light. It's about the structure of the system, regardless for the cause of such shape. Indeed, if we could manage the same arrangement without using electric or magnetic fields, the splitting here would be the same. To recap, light is considered a self-inducing, self-propagating fluctuation of the electromagnetic field, but these fields are not its medium. The self-behaviors are more troublesome than problem solver, and light never shows electromagnetic interactions. It is also really hard to give meaning to this lack of polarity. What remains of an electric field when we remove the charge? theory won't match reality. We already saw propagation of light is underdefined, and the Doppler effect can't take place without medium. We now add that it is wrong to consider light a form of electromagnetic energy. And we must mention gravity because it shouldn't have nothing to do with any of these, yet it's the only field proved able to interact with light. So the initial assumption is inconsistent. Light is not electromagnetic just because it moves at c, or because it's emitted by charged particles. All matter is made of charges, even neutrons, so the hard part is to find something where charged particles are not involved. And this comes from the fact that too often scientists seek only agreements to prove their truth.